In this video, I want to take a look at some issues that arise when we try to remove elements from lists in Java. So to start out, what I did is I just made an array list called names, and I added a bunch of people to it, and I printed it out just to confirm that they're ordered the way I expect. Okay, so everything looks good so far. And I've got a template for a remove all function up here. And what the remove all function is supposed to do is take a list argument and a value, and I want it to remove all instances of whatever value I pass in from the list. And so, my method call, I'll say remove all, and I'll pass in the named list. And let's suppose I wanted to get rid of all of the Charleses in the list. So what I'm going to do, so this will be the method call for that, and then I'm going to print out names at the end, just to confirm that it actually works. Okay, so an obvious solution to this, so you would say, well, let's just loop through it, and every time we see every time we see a Charles or whatever value we pass in, we'll remove the element with that index. So let's see how it works. So we'll go from int I equals 0, I is less than list.size, I plus plus, and then I'm going to say, let's say if list.get I dot equals value, and we will remove, it'll be list.remove I. Okay, so that seems simple enough, and let's run it and watch what happens. And so here's my first list, and it's got a Charles here, and it's got a Charles here, and I run it again, and they're both gone, so that seems to be good. But you may have noticed just a second ago, and I deleted one of the Charleses from the list. Right now I am covering up a bug in this code, and so I'm going to go put another Charles in the list. And so this time when I run it, you can see that, let's see, one of the Charles between Bill and Jean, one of these two Charleses is still in the list, and the other one got removed. So there's a problem when I have adjacent values that are the same. And so let's think about why. All right, so the indices here is, I've got another list called letters, and let's say my call is remove all letters, and I just want to remove the C's. So my indices are 0, 1, 2, 3, 4, and 5. And when I loop through, right, I check element 0, it's not a C, so we don't remove it. Check element 1, not a C, so we don't remove it. Check element 2, okay, it's a C, so I call remove. And when this element goes away, everybody slides over. And then, right, remember, when we removed this C, the list index was 2, and on the next iteration of the loop, the list index will be 3, but the C isn't there anymore. The C is over here. The D is in this spot. So we actually never looked at the second C in the list. We skipped over it because of the way everybody slides over when you manipulate an array list. So let's go look at some solutions for this. All right. One way would be to go, oh, I got it. Whenever we remove something, we'll just back up a slot when we iterate. And so, we go over here and we, that's fine. We remove the element 2 and everybody slides over. So we just take I and we reduce it back to 1. And then when we reach the end of the loop body right here, I increments and it increments back to 2, and we end up looking at that same slot again. So this solves the problem, but I'm not particularly fond of this solution, just because I think the whole purpose of a for loop like this is that you can see exactly how the counting, the beginning and the end and what you're counting by, you can see it all in one place. That's what makes for loops nice and readable. So we've got a couple alternatives to this. One way would be, right, let's iterate through the list backwards. And so the last element is I minus 1. And we'll loop so long as I is greater than or equal to 0, and we'll count down. And this works just fine. Okay, and all of the Charleses got removed, so that's good. And hopefully it makes sense, right? So we got 0, 1, 2, 3, 4, 5. Right? So we start at the back of the list, and not a C, not a C, that's a C. So we remove it, and the D slides over, and the E slides over, and that's fine. And the list is one element shorter now. So when we remove the C, the index was 3, and on the next iteration, the index goes down to 2, and we remove it, and everybody slides over. So when you're counting backwards, it's fine because all of the moving of the list is behind where you're iterating, and so you don't have to worry about it. Okay, so I think looping backwards is a rather nice solution to the problem. I'll show you one more. Let's say, I guess I don't need this anymore. And I'll show you one more strategy if you don't like the looping backwards, and that is use a while loop instead. So I'm going to say int I equals 0, and I'll just say while I is less than list.size. And then I can say if, let's see, it'll be list.get I dot equals value. And then we'll say list.remove I. And normally, when we write a while loop, we might do something like this, right? So this has, so if we run this, right, this has the problem, the same problem of skipping over elements that the forward for loop did. But what we can do instead is just increment the I conditionally. So what we're going to do now in this one is if we remove an element, we'll let I sit on the same place. And that way, when everybody slides over, we end up looking at that spot, right, at least one extra time. And we'll only increment I if there wasn't a duplicate, or if there wasn't a value in the list that we're going to remove, right? So we go, don't remove, and I is 2, and we remove Charles, and everybody slides over, and we sit on that index again. So when this Charles slides in, it still gets looked at. All right. So when you're removing things and looping through a list, you have to consider, right, consecutive elements. Okay, I think that's the big thing to consider. Now, one more thing that you might think, it's like, well, wait a minute, let's forget about the index altogether and try this with a for each loop instead. So let's try for, and I'll say string item in list, and I'll say if item dot equals value, and we'll say list dot remove item. And remember, we can the remove function can take 2 kinds of arguments. You can pass in an index, or you can pass in a reference to an object that you want to remove as well. And so when I try this, right, we get an error, and it says a concurrent modification exception. Whoops. So we get a concurrent modification exception error. And basically what that's telling us is that using a for each loop, you're not allowed to add and remove items during iteration. And I think the reason for this would be, we have this issue of when you add items or remove items, the things are shifting over, and the question is, what do you want to do with the index when that shifts over? And using this kind of loop, there's no way to specify how that's going to be handled, and so they just don't allow you to do it. Just don't allow you to do it this kind of loop because what is happening is unclear. All right, so I hope this video makes sense and is helpful. And if you have any questions, go ahead and let me know.